Section 4. You will hear a university lecturer giving a talk on the effects of microplastics on marine life. First, you have some time to look at questions 31 to 40. Now, listen carefully and answer questions 31 to 40. Good morning, everyone. Today's lecture will focus on a pressing environmental issue, the impact of microplastics on our marine ecosystems. Microplastics, as the name suggests, are tiny plastic fragments defined as being less than 5 millimeters in size. They represent a widespread and incredibly persistent form of pollution that has infiltrated every corner of our oceans. Understanding their origins is crucial, as they stem from a variety of sources, making this a complex problem to tackle. So let's break down where these microplastics come from. We can generally categorize them into primary and secondary sources. Primary microplastics are those intentionally manufactured as small particles. A common example that many of you might be familiar with are the microbeads, once found in numerous cosmetic products like facial scrubs and also in certain cleaning products. However, another major and often overlooked source of primary microplastics comes from our clothing. Synthetic fibers such as polyester and nylon are shed from our garments every time we wash them, entering the wastewater system. Secondary microplastics, on the other hand, result from the breakdown of larger plastic items. Think of plastic bottles, bags, and fishing nets. The main culprit in this degradation process is exposure to sunlight, which causes what scientists call photodegradation. Over time, the sun's UV radiation weakens the plastic, causing it to fragment into smaller and smaller pieces. It's important to note that the type of the original plastic item, whether it was rigid or flexible, for instance, significantly affects the characteristics of the microparticles formed. Now, let's consider the devastating impact these tiny particles have on marine life. One of the most direct effects is ingestion. Animals at the very bottom of the food chain, such as plankton, consume these particles, mistaking them for food. This then has a cascading effect throughout the food web. When marine organisms ingest microplastics, it can lead to internal injury and a false sense of fullness, resulting in starvation. This problem isn't confined to tiny creatures. It affects animals of every size, from small fish to large whales, all of whom can consume contaminated prey. Beyond physical harm, there's also the serious issue of chemical contamination. Microplastics have a remarkable ability to absorb harmful chemical toxins that are present in seawater. These chemicals, like PCBs and DDTs, are then transferred to the animals that ingest the plastic. Studies have shown that this chemical transfer can have a significant and detrimental impact on an animal's reproductive system, compromising their ability to breed and maintain healthy populations. Looking ahead, there are significant challenges in addressing this problem. The incredibly small size of microplastic particles makes their detection and removal from the environment very difficult indeed. Furthermore, the problem has a truly global distribution. Microplastics have been found everywhere, from the pristine ice of the polar regions to the deepest sediments of the Mariana Trench. This widespread presence makes containment incredibly hard. While more research is urgently needed to fully understand the long-term effects, scientists are already working on solutions. For example, new filtration systems are being developed and implemented in wastewater treatment plants to capture plastic fibers before they reach the ocean. Ultimately, however, the most effective and lasting solution will undoubtedly involve a significant reduction in our overall plastic consumption. It's a problem that requires both technological innovation and a fundamental shift in human behavior.